Today we're going to learn about proportions and probability. If we want to understand proportions, we need to understand the idea of having an experimental probability. And if we look at the word experimental, we can see that it has the word experiment. If we know what it means to experiment, that really helps us to understand the meaning of this definition. So experimental probability is the number of times an event occurs. You could also think of it as the number of times the experiment occurs over the total number of possible outcomes. So, if I gave the example, again, of flipping a coin, I know that a coin has two sides, and one of the sides is heads. So the theoretical probability would be that if I flipped it, I would land one time on heads, or I might land on tails. But the experimental idea is that, say I flip a coin 1,000 times. So we're going to say that I flipped it 1,000 times, and on 480 of those times it landed on heads, and on 520 of those times it landed on tails. So you have to ask yourself, does this make sense? And in order to know if it makes sense, you have to realize that out of the 1,000 times, half of that would be 500. And half is our theoretical probability for both sides of the coin. So 480 is pretty close to 500, and so is 520. So in this case, yes, it does make sense. So if we have an example of our own, I'm going to say I have a bag of marbles. And in the bag of marbles there are, I'm going to make sure to say that I have pulled out, not that there is this exact number, because there is a difference with experimental probability. So I pull out 4 blue, 3 red, 2 yellow, and 1 green marble. What I want to know is how many I can find, how many should I expect to find of each color. In a bag of 132. And in order to do that, I need to set up a proportion. So I need to know how many I pulled out total. So I pulled out 4 blue plus 3 red plus 2 yellow plus 1 green. And 4 plus 3 plus 2 plus 1 is 10. So out of 10, 4 of them were blue. And I need to set this up as a proportion. The total number that I have in the bag is 132. So X will go here. If we remember how to solve proportions, we cross multiply. So 10 times X is 10X, and 4 times 132 is 528. If I divide both sides by 10, I'll get X equals 52.8, but I know I can't have part of a marble, So I'm going to round this to 53 marbles. And these were blue marbles. I'm going to ask myself that same question, does this make sense? And I know 4 out of 10 is about half, and 53 out of 132, that's about half, so it makes sense to me. It's a little less than half, but 4 is a little less than 5, which is half of 10. I have 3 out of 10 that were red. Again, I'm going to cross multiply. So I get 10x equals 396, and I divide both sides by 10. And here I have x equals 39.6. Again, I can't have part of a marble, so I'm going to round this up to 40 red marbles. Next up, I had 2 that were yellow out of 10. My total was 132, so I cross multiply. I'm going to get 10x equals 2 times 132 is 264. I'm going to divide both sides by 10. And here, x equals 26.4 marbles. Again, I can't have part of a marble. I'm going to round this one down to 26 yellow marbles. And I have 1 left. 1 green one out of 10. Cross multiply. Then I divide both sides by 10. And x equals 13.2. I know I can't have part of a marble again, so I'm rounding that down to 13. Now I need to ask myself, if this makes sense. So I already asked that for blue. For red, 3 is about 1/3 of 10. My final answer was 40. That's about 1/3 of 132, so this makes sense to me. 2 is 1/5 of 132. So this is 26, that's about 1/5. I know if I multiply this by 5, it should be about 132. And 1 was 1/10 of it. And 13 times 10 should give me about 132. Another way to check it is if I add all of these up, my answer should be right around 132. So I'm going to go ahead and do that. 53 plus 40 plus 26 plus 13. And that's exactly what I get. So I know that this works.